Okay. Good evening, guys. Yes, I think we can do it. Correct. So, how was your? How was the last week? Hmm? So last week we had the result board, So how was it? Did you visit any Dansal or any other places? Hmm? What was the last week? I told you in the last week, be careful in this week. So, did you visit any place? Anywhere? Someone? You can just put messages. No. Why? The neighborhood? Hmm? Okay, it's okay. Actually, I have visited double. Okay, so because I am Matale, so good. Actually, we have made the Vesak Canton from the power day. I told you in the last week. After this class, I have to make the Vesak Canton. Okay, so last week in Sunday, no, last week Sunday, I made the Vesak Canton. Right, and the thing is, the power day we have visited double because. I'm Matale, and double is in our area. So actually, we had visited around 15 dancers in both days. So in the Poe day and also the day after the Poe day. Okay. So that's about us. Okay. Us means me and my friends. Okay. So I think so I have given the link for the registration. Okay. I think several students have registered to the class, and Altaf has registered to the. I think you registered. I didn't see in the grade 11 class what Google Form, but several students has registered in the LinkedIn. Okay, good. So actually, I told you in the last week. So we are going to collect that email, and also so we are going to give the video recording access to that email. Okay, so make sure you are going to watch the recordings using that email. I think you are IT students, no? So I think you know how to use your own email to the YouTube. Okay. So if there any problem, you can tell me. Okay? You can ask me. So I will guide you how to check the email, and I will change the change the email to yours one. Okay. So if there any problem in when you viewing the recordings, just tell me. Okay. And also we have collected the what addresses because we're going to post your tudes. Okay. So but as I told you in the last week, once you what pay the first month fee, I will deliver the tudes. Okay. So that's about the tube. Okay. So let's start the class before telling other things. Okay. So as I remember, we have stopped in the binary number system. No? I think we have discussed about the number system and what are the number system, and why we are learning this number system, and what are the things inside this number system lesson. Likewise, we have discussed about those things, and I think we have discussed about the decimal number system. No? The first one. The first one, yes. I think we have discussed about the weighting factor. Okay. We have discussed about the weighting factor and the decimal number. Yes. Okay. So today we are going to start the binary number system. Okay. Binary, and we have to discuss about octal and the hexadecimal. Okay. So then we are going to move to the next step. That means we are going to convert within those number systems. Okay. We are going to learn how to convert within those number systems. Okay. All right. Let's move. Okay, let's move to the decimal number system. Decimal. Okay. No, not decimal, no, binary. Binary. Okay. binary number system. All right. So as you remember, so number system name begins. We are consider the number system name as the characters, no, symbols inside that number system. Okay? When we call by decimal means I told you it is 10. No, decimal means 10. Okay, we are going to use. So I think we have wrote the table. In the table you have wrote the base is 10. That means the decimal number system means 10. That means in the decimal number system we are going to use different 10 symbols. Okay, what are those? 0 to 9. Okay, once we calculate from 0 to 9, there will be 10 different symbols. Okay, so then when we consider binary means, okay, binary, binary means, guys, 2. Okay, binary means 2. That means in the binary number system we are going to use only two symbols. What are those? 0 and 1. Okay, in every number system we have several number of symbols. Okay, every symbol will start from 0. Okay? Every symbol will start from 0. Good. 0 and 1. Yes. Okay. So when we write the base in this binary number system, base will be 2. Okay. So base is coming with the name actually. So second base is 2. Okay. So what are the digits? Digits. I told you digits means symbols. Okay. Digit means symbols. So what are the digits we are going to use in this one? Digit used, as you told earlier, 0 and 1. Okay. Only 0 and 1 digits are using in this binary number system. Okay. So what is the weighting factor? Weighting factor, I told you. Weighting factor. This is 0. Weighting factor should be what? 10 to the power 0, 10 to the power 1, 10 to the power 2. Sorry, not 10 to the power. Okay. Second to the power. This one. Okay. 2 to the power. 2 to the power 4, 3. Likewise. The weighting factor will be coming with the 2 to the power. Okay. So very easy, very easy. So all the things is in based on the name, guys. So when we discuss about the decimal means you have to remember decimal means 10. Okay. Binary means 2. Octal means 8. Okay. So actually, so I will tell you in the octal number system. Okay. So likewise, here we have binary means the base is 2. When we consider base, that means there are only 2 digits are going to use. So when we consider 2 digits, as I told you, every digits will be start from 0. So when we have 2, we are going to put 0. This is 1 and 1. This is second digit. Only 2. So when we consider weighting factor, it is also based on the base. Okay, 2 to the power 0, 2 to the power 1, likewise. This is the second, binary number system. Okay. So actually, guys, last week, I told you, computer can only understand this number system. Okay. We are going to use several number systems in our computer system. Okay. What? Binary, decimal, okay, octal and hexadecimal. There are 4 number systems we are going to use in our computer system. But the thing is, computer can only understand this binary number system. What is the reason? Okay, all the things I have told you. Okay? What's the reason? The computer is using digital signals. Okay? Digital. That means there will be 2 states, only 2 states, like this. Okay. So here we are going to consider this one as 1. This will be 0. 1, 0. Likewise. So computer is an electronic device. Okay. So it is going to use DC current, okay, DC current, digital current, and also as per the signals, they are going to use digital signals. Okay, you can see here. So when we consider digital signal, there are only two states in the digital signal. Those are the ones and zero. That means high voltage and low voltage. Okay, only two symbols: high voltage and low voltage. So we are going to assign one to the high voltage signal. So when it is come to 0, that means low voltage, we are going to consider that one as 0. Okay. This is why we are telling that our computer can only understand what is this? Binary number system. Okay, binary number system. We are going to call this zeros and one as machine language. Okay, machine language. Machine language is the language that computer can only understand. Okay, machine language. In the machine language also, we are going to code. Okay, machine language is going to use for programming. Okay, programming. That means give some instruction to the computer. Okay, so when we write programs or as instruction in the machine language, we are going to only use zeros and ones. Okay, this is also like binary number system. No, this is also like binary number system. So we are calling this one as machine language, and also we can tell guys, we can tell binary number system is the number system that computer can understand. Okay, as well as the machine language. Okay, same thing. Actually, machine language is the one computer can understand. But you can see when we write in machine language, we are going to also use, we are using only two symbols, no? Two symbols. Okay, guys. So when we consider binary number system, here also we are going to use two symbols. So that's why we are calling those two are like equal. Okay. So we can only understand this one. Okay. Get it? Okay. Is it okay? Just raise your hand. Okay. I will ask several questions. So you get it or do you have any questions likewise? Okay. So if you don't have, just raise your hand. Okay. All right. So let's write. Okay. Let's write those things. Okay. So put the title. Okay. Subtitle. Okay. Binary number system. Second one. No. Second one. Binary number system. Binary number system. Okay. Right, like this. This number system use this number system use this number system use two different symbols. Two different symbols. This number system use two different symbols to represent numbers for values. Two different symbols to represent values. This number system use two different symbols to represent values. Okay, just write this. Write like a table. Okay? Just draw a table, or else just write. So there is a table including our tube. You can fill out the table using these things. Okay, just write these things and raise the hand. You don't finish? Okay, good. So let's take an example for a number. Okay, for a number, let's see like this 1 0 1 1 0 1. Okay. This is the number of the binary number system. Okay, so when we consider weighting factor, what will be the weighting factor of this one? The last one, I mean right one. Okay, the right side last one. This one will be 2 to the power 0. Okay, the weighting factor will be 0, guys. Okay? In every number system. Okay? This one will be 2 to the power 1. No, I think you can remember this one. 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. Okay, likewise, the weighting factor will be assigned to this value like this. Okay, all right. So there is another important factor in this binary number system. Okay, so I told you computer can only understand this one. That means machine language or else binary number system. Okay, so when we consider binary number system, I told you here we are going to give some signals to the values. You know, if we give 1, that will be high signal. If we give 0, that will be low signal. Likewise, guys. So we can consider, actually, we are considering this one value as the smallest value of our computer system. When we consider capacity, of our computer system, I mean, there are megabyte, gigabyte, likewise, you know those things. Okay. So when we consider the creation of that capacity, creation part, the smallest part, smallest capacity is this one digit. Okay? One digit of the binary system. You know, as here actually here there is this can be tell as one instruction. One instruction or one file. Likewise, we can tell this one as a, let's see, one file. Okay? One file. This is a file. Okay. So as you can see here, we have used several symbols. Okay. So that means this one symbol is the smallest capacity, guys. Capacity of our computer. Okay. This one symbol. Okay. We are calling this one symbol as bit. Okay. So bit is formed by binary digit. Okay. You know, digit means okay. Digit means one symbol. No? Here we have used actually. Digits used mean here we have used two symbols. Okay. That means this one symbol can be told as binary digit. Okay, I think you have understand that one. So when we consider this name, we are going to separate several characters. Okay, several characters. That means okay, these two. Okay, these two. BI and this T, or else this B and this IT. Okay, you can consider either of these two. Okay, so when we consider these characters, okay, character means one symbol, my friend. When we consider these characters, we can write bit. Okay, bit is the smallest value of our computer system. Okay, smallest value of our computer system. In later on this lesson, we are going to learn what are the capacities, what are the names we are going to use for the calculate capacity. Okay, refer capacity. Okay, so just remember, bit is the smallest capacity, guys. Okay, so that means bit is represented by one digit of our binary number system. Okay, get it? Okay, no? Good. Let's write that down. Okay, just first write example, and then first write this thing, only this one. Okay, not this part, only this one. And yes, you can write this one also. Okay? You can write this one also. We will write the note below that one. Okay? You can just write this one and this one also. Doesn't matter. And when you finish, just raise your hand. Our Vesak lanterns are still hanging. So they will hang until Poson is gone. Poson came. So after that, we are going to remove that. I think that will be the procedure of every home. I just finish these things. Okay, good. Okay, Altaf? Yes, good. So let's write. Okay. Uh, write like this. The binary number system. The binary number system is very important in our computer technology. The binary number system is very important in our computer technology. And contributes to the creation of bit. Creation of bit. Creation of bit. Creation of bit, comma, which is the basic unit of measurement in computer. Which is the basic unit of measurement in computer. Which is the basic unit of measurement in computer. The small, right to that paragraph. The smallest value in this number system is 0. And the largest is 1. And the largest is 1. The largest is 1. These values are known as these values are known as a bit. A bit. These values are known as a bit. Okay. Okay. Are we clear this? Okay, let's see. Let's move to the next number system, which is octal number system. Okay. The next one is octal. You know, did you know that we have had a processors? We still have the processor like octa-core. We have several processors. They are naming as octa-core processors. Octa-core. That means inside that processor we have 8 cores. What is a core? What is a core? I think you have learned in your school about CPU, no? Central Processing Unit. I think you know those things. Okay. So actually, when we consider our computer, there is a small part. We call this one as a brain. Okay. That is the part that manage everything in our computer. Okay. We call this one as CPU, Central Processing Unit. Okay. Inside the CPU, we have several things. What are those? We have registers, okay. registers, and we have ALU. ALU, that means arithmetic and logical unit. And the last one is control unit. Okay, CU, not the Tata by CU. Okay, it's control unit. Control unit. Or else when I say CU, you will say, okay, sir, see you, bye, then leave. Not that time. Okay, control unit. Okay. This is like a brain, no? In our computer, this is like a brain. Okay. When we in the oldest computers, okay, in the oldest computers, we have only one CPU in our computer, in our processor. Okay. Only one CPU. But when we involve our processors, we have included several CPUs. Okay, several CPUs. That means after this one, we had processors that included two CPUs. Two CPU. CPU1, CPU2. This is the processor. Processor is the hardware part. Right? Hardware thing. I think you have touched a processor, no? Processor is the hardware part. CPU is the block diagram that is that included in the processor. Okay. When we consider this processor, they have included two CPUs. That means like two brains. We are calling this one as dual core. Dual core. Actually, guys, when we input two CPUs, we are referring one CPU as a core. One CPU as a core. That means inside this CPU, we have registers, ALUs, and control units. Okay, control unit. Likewise, this CPU, this one has also what? Registers, arithmetic and logical unit, control unit. Those are the things are dual core processors. Okay. So it was involved. It involves about four. What is the name of four? I don't remember the name of the process that have included uh, four CPUs. I don't know. Okay, I can't remember, guys. So it has involved, that means the processor has included 8 CPUs. 8 CPUs. Those CPUs are called as octa-core octa-core processor. Okay. So those processors are still available in our mobile devices. Okay. Integrated graphic cards means separate graphic card, guys. No, not the separate. Yes. No, actually, so oh, you told me that this can be referred as the integrated graphic card. Yeah. No, actually, when we consider there are only two processors that two cores that will be dual core. Okay. So what is the integrated graphic cards? Okay, integrated graphic card means, guys, actually inside our processor there will be a separate graphic processing units. Okay? Separate graphic processing unit. So we are calling those processors as APU processors. Okay, so that means in here we have a separate GPU, graphic processing unit. GPU means graphic processing unit. Okay. Here we have the GPU, and here we have cores. Okay, this will be one first core. This will be second core. Okay, and also, guys, when there are several things inside the CPU actually. Okay, when we move to the A layers, you will know there will be a cache memory. Okay, cache memory inside our CPU. Okay, we have to actually add that one. Okay, I didn't tell you because in your O-level syllabus they didn't include that one. Okay, actually we have a cache memory also inside our CPU. Okay, so here actually, guys, there will be a separate graphic processing unit. This is our processor. Okay, inside the processor there will be a separate graphic processing unit, and here we have one core. Here we have another core. Okay, and here actually we have a shared cache memory. Shared cache memory, level 2. Like, okay, there are several levels in cache memory. Okay, this cache memory will be shared by this first core and the second core. I will show you a picture, actual physical picture. Okay, so actually this is beyond the lesson. Okay, so give me 1 minute, guys. I will show you the picture of actual process. Uh, 1 minute, right? Okay, here I think you can see. Where is my mouse? Okay. Here you can see this is a picture of an actual processor, guys. So here actually we have a separate processor graphic. Okay, processor graphic. So that's the thing we are going to call that. You're going to call that integrated graphic like this. We actually we have included 4 cores. This is the level 3 cache. Okay, this is the level 3 cache. Likewise, is a memory control hub. Likewise, there are several things inside our processor. Okay. So here actually those are the examples for 4-core processor and 6-core processor. Likewise. So here you can see, okay, single core. Okay, single core means there is only one CPU. That means only one core. This is a dual core chip. Okay, you can see here level 2 cache will be shared, and here level 1 cache will be added in separate for each CPUs. Okay, so those are the dual core. Here, those are the example. Intel dual core. Intel Core 2 is a dual core processor. Is a dual core processor, right? Also multi processor. I have to show you what this one. Okay, those are the processor types. Just skip this one. CPU means, guys, there will be only what? Only processing, not the graphical processing unit. Only as a system that are going to process data. Okay, not the graphic. Those are the APUs, accelerated processing unit. So these processors has combined of CPU and GPU. GPU means what? Graphic processing unit. Graphic processing unit are the processors that are specially designed to make graphic, okay, handle graphic. So when you buy NVIDIA graphic card, NVIDIA like this, there are several graphic cards. So inside that graphic card, we have a separate, okay, we have a separate graphic processing unit. Okay, so CPU is inside that processor. We have only what part that can handle data. So integrated graphic means these APUs. Okay? That means normal people know integrated graphic as what onboard VGA. You know, that means they are thinking that graphic card will be integrated on our motherboard, but that is wrong. Actually, that graphic card is integrated in our CPU. Okay? In our CPU, those processors are called as APUs. Combine CPU and graphic card, GPU. So actually, in my computer also, I have this kind of one APU. Okay? I have APU. Can show you. I will show you. Okay? So here you can see this GPU 0 is the one that is the graphic unit inside my CPU. Okay, you can see here actually, guys, this GPU is running over 15%. No, you can see CPU is running over 67, 47, like I say, it's very high. That means those two are included. This 75 is included with this 20 or 30, like that. Okay. This GP1 means my separate graphic card. Okay. Okay. That is about integrated graphic card. So as you ask, okay, as you mentioned, not ask, no. You have mentioned, no? That's why I told you. So the thing is, this one are calling as octa-core processors. Okay, octa-core, that means, guys, 8. Okay, the point is actually octa means 8. That is the point. That is the point. That's why I have told these things already. But keep these things mind, okay, because those are ICT. Actually, those are beyond your syllabus. Okay, as I told you, I will be teach you several things beyond your syllabus. Okay, but those are very important to your life. All right. So as you can see here, when we have multi-core, that means our computer will be speed up. No? When we have multi-core. So actually, in i7, there will be 10 or 12 cores. Okay. So when we consider i3, there will be only 3 or 4 cores. Okay. There There is no any 3 cores computers, but there will be 4 computers. Okay? 4 cores. So when we consider I5, there will be 4 or 6 cores. Okay, likewise. When we consider I9, there will be, I think there is 18 cores. Okay, there is 18 cores, I think. Okay? As I remember. Likewise, the capacity of cores will be maximized. Okay. All right, so I will just clear this thing. Okay, so octal number system means, guys, 8. Okay, that means base. What will be the base? The base will be 8. Okay? Base will be 8. Okay. So when we consider the digits that we are going to use, that means it is also 8. That means we can start from 0, 0, 1, 2, 3, 4, 5, 6, 7. Okay. When we consider these things, there are 8 symbols. Okay. Weighting factor. What is the weighting factor? 8 to the power 0, 8 to the power 1. Likewise, this. Okay. As the example, so here I will write 7. Okay. I will write like this. You have to put your base on in here. Okay. When we write a number, you have to put the base. Okay. So what will be the weighting factor of this? This will be 8 to the power 0. This will be 8 to the power 1. 8 to the power 2. Very simple. Very simple. Okay. Did I mention what are the valid numbers that we can insert to the number system? Did I mention that one? So if we consider octal number system, what will be the valid numbers? What can be the valid number? Did I mention that in the last week? I don't remember, guys. That's why I'm asking. No. No. Okay. I will just write in here. Okay. I will just tell you guys. So when we consider octal number system, guys, we can write just 247. It is okay. Okay. If we write like this, 248, is this can be octal number system? Is this can be octal number system? No, no, because actually 8 is not a symbol, not a digit in octal number system. No, 8 is not a digit. So if you got a question like 248, and they are going to ask this what are the number system that we can use this number? Okay, what are the number system? This number can be included. Okay, so is it can be included to the binary number system? Binary number system. In the binary number system, you know, we have only 0 and 1. So there are 2, 4, 8. That means this number cannot include to the binary number system. Okay. Octal. When we consider octal, in the octal number system, digits are going to value between 0 and 7. Okay, but here actually 2 is okay, 4 is okay, but 8 cannot be a digit in our octal number system. No? Cannot be a digit. That means this is not belongs to octal number system. Let's see about decimal. Decimal, you know decimal number system. The decimal number system, we have 10 digits. That means 8 is one of those digits. That means 2 is a one digit of decimal number system. 4 8 also a one digit of decimal number system. That means this number can be a decimal number system. No? Can be a decimal number system. Okay. And what else? What else? You don't know yet about the hexadecimal. Okay. But you know a little bit, no? I told you in the last week. When we consider hexadecimal, guys, in hexadecimal also we have those digits. Okay, we have 2, 4, 8, 0. Likewise, we have all the symbols or else all the digits inside the hexadecimal as well as what decimal number system. That means this number can also be a hexadecimal number system. Hexadecimal number system. Did you guys understand? There can be a MCQ question, okay, like this. So they will give you a number and asking what are the number system this number can be included. Okay. So if you wrote 8, so octal, here you have 8. That means this number can also equal to octal number system. That is very low. Okay. Remember those things. All right. Let's write octal number system. Just write the topic octal number system. Octal number system. Octal number system. Right. This number system uses 8 different symbols. This number system uses 8 different symbols to represent values. This number system uses 8 different symbols to represent values. And write this table. Draw this one. Draw this table and also this one. Just write example and write this one. I will write now. Example. Example. Okay. Don't write this one yet. Let's first let's learn about the hexadecimal, and then we can we will write this one. I will give you this one as a question, so then you will remember this. Just write these things and just hands up. Okay, good. Let's move to the next number system, hexadecimal. I have to clean this. The space is not enough. Hexadecimal number system. Okay, I will speed up. I think you guys understand now. Okay, hexadecimal means, guys, 8. Sorry, 8, not 8. 16. Okay, hexadecimal means 16. Okay, you have to understand those values. Okay, octal means 8. Likewise, you have to remember those things. Okay? Hexadecimal means 16, guys. Okay? 16. That means when we talk about the digits, we are going to use 16 different symbols. No, we are going to use 16 different symbols. I told you, when we write down the digits, we will start from the 0. Okay? We will start from 0. So here actually we have 0, 1, 2, 3, 4, 5, 6, 7, and 8 and 9. Okay. There are how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. We have 10 digits using these numbers. Okay. So can we write 10? Can we write 10? I told you no. We cannot write 10 because here you can see 10 is this digit and this digit. No? When we combine those two, 1 and 0, it is the value of 10. Okay? That means here we have used two symbols we already have used. No, that means we can't use 10. Okay, but we should need a symbol to represent value 10. Value is a different thing. This is a symbol, guys. Actually, for all the number system we have learned yet, okay, the symbol is the value. Okay, when we talk about octal and when we talk about hexadecimal, sorry, not hexadecimal, binary, and we talk about decimal, we have used several digits. Okay, those are the digits and characters. Okay, so there is a value inside that character or as digit. Okay, I will call digit. Okay, digit mean one digit. Okay, one character. I will call digit. So this is a digit, but there is a value inside this digit. Okay, so actually value is also 1. Here value is also 2. Here 0, 3, 4, 5, 6, 7, 8, 9. Okay. The shape is 6. This is the digit. Okay. Inside that digit, we have a value. It is also the 6. Okay. So here we have the 9 like digit. Okay. 9 shape digit. Okay. So then we have to use another symbol or another digit to represent value 10. Okay. I told you this number system were made by English people. This number system were made by English people. So they have used their process symbol. Okay? Their process symbol was their alphabet. Okay? Their alphabet was the process symbol. So then they have used A as a character or a symbol or a digit. Okay, but the value is 10. Value is 10. Okay? So we can insert B. The value is what? Value is 11. Okay. Likewise, we have to use 16 digits. So until now, we how much we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. 12, 13, 14, 15, 16. Okay. Until 16 digits or 16 characters, they have included alphabets. Okay. But the value, just remember, okay, digit is one thing, there is a value. Okay. Value here it will be 12, 13, 14, 15. Okay. The value is 15. This is about the hexadecimal, guys. Okay. There is a little bit confusion, but I think you got that one. Okay. This is the hexadecimal number system. Okay. Those are the digits we are going to use. And what will be the weighting factor? This simple, no? Is as always 16 to the power 0, 16 to the power 1, 16 to the power 2, likewise this. Okay. It is same as previous number system, but those things are the things that they have changed. Okay? So think about this. So you are the person that create hexadecimal number system. number. What? Okay. You are the person that create hexadecimal numbers. So what will be the 10th digit? Okay. 10th digit. It can be anything. Okay. If I was the person, I will just include flower. For this one, I will include tree. For this one, I will include car. Okay. Likewise, any symbol can be represent the value. Okay. Value should be same. We can't change the value, but symbol can be changed. But actually, this one is published. Okay. So don't put flowers and trees. Don't put flowers and trees. Just ABC. Right. So let's write the topic hexadecimal number system. Hexadecimal number system. Yes, hexadecimal number system. So as the example, I can write E. Okay, 240 E. Okay, E is included in the digits in hexadecimal. Okay, let's write. This number system use 16 different symbols. This number system use 16 different symbols to represent values. This number system use 16 different symbols to represent values. They write these things, these three, and write this example also. Raise your hand, right? Once you finish. Okay, let's write a question. Okay, let's write question one. Question one, or else just question. Okay, right. What can be the number systems? What can be the number systems of following numbers? What can be the number systems of following numbers? This is the first one. 248. Just don't put the base. Okay, don't put the base because this is a question. 248 can be decimal and hexadecimal. Just write 240 and just write a dash or something. Decimal and hexadecimal. Okay. The second number. Okay, right, for this 5, I have teach you this one. Okay, so what can be the number system for this one and this 3? Just write and hands up. Good. For everything? Good. Let's wait for others also. When you finish, just raise your hand. Good. Janot, finished? Good. Let's see. Okay. What can be those number system? Here we have 1, 4, 3. That means we cannot include this number as a binary number system, but in octal, hexadecimal, and also in decimal. Both, all the 3 number systems can include this number. Okay, not only one. Okay. There are 3 number systems. Likewise, here we had 2 number system. Here we have octal, hexadecimal, decimal, and hexadecimal. What about this one? A, there's a A. That means the A digit is only in the hexadecimal. That means this one can be only a hexadecimal number. Okay. Here, what about this one? 100. Okay. Yes. This one can be binary. Not only binary. Okay. Not only binary. This one can be binary, octal, decimal, and hexadecimal also. Okay. Because in every number system, we have 1 and 0. Okay. Not only one number system. That's the thing you have to learn. Okay. Here, we have 1, 0, 1, 1, 0. Here we have 2. So that means 2 cannot be in the binary number system. These things can be in the binary number system, but 2 cannot be. That means this is not a binary number system value. This can be octal, decimal, and hexadecimal. Okay. Correct? Correct? Okay, good. So I'm going to tell you something about the hexadecimal number system. A place that the computer is using this hexadecimal number. Okay. So actually, guys, when we consider our monitor, okay, monitor is going to display every colors. No? So when we consider monitor, monitor is showing us every colors. Okay. Actually, how it is generating those colors? The monitor is a device that have black background. Okay, black. The monitor has black background color. Okay. When we have black background, we can use red, green, blue. Those three colors to create any color. Okay. Those three colors, when we have a background, okay, when we have a black background, that means our monitor using black background, okay, we can use red, green, blue, these three colors to create every color in, okay. That's how our monitor is working, okay. Actually, our monitor is going to use red, green, and blue LEDs to represent one pixel. Okay, pixel is the smallest color, smallest unit that can show color. Okay. So using these three colors, we can create any value. So any color. Right? That means, let's say, if we put 100% of red and 0% of these values, these colors, what will be the color? The color will be red, no? Because 100% red. Okay. So if we put 50% red and 50% blue, sorry, green, color will be, I think, magenta, or right, rose, like white. Like I don't know. Let's see. Okay. So if we get 50% of green and 50% of blue, the color will be like aqua. Okay. Aqua means light blue, like. Okay. This is about the monitors, guys. Sorry, monitors. When we consider monitor, monitor. So when we consider printer, what will be the colors? Printer. Okay. When we using printers, are we going to use background? We are going to use a paper to print. No? When we using printer, we are going to use paper to print. Okay. Is the paper is in black? No, no. Paper is in white. No. Paper is in white. That means when we use printers, we are going to use white background. Okay. We are going to use white background. When we use white background, we cannot use these three colors to create any color. Okay, we cannot use these things because the background is changed. Okay, so in that case, actually, we have to use CMYK. Okay. C means cyan, M is magenta, Y means yellow, okay. K means key, guys. Key means black. Okay, we are going to use these four colors when we are printing using printer. Okay. We have to use cyan. It is like a light blue, okay? A light blue. Magenta, this is Geo. Yes, this is magenta. It is like a pink, yellow, and key. Okay. When we talk about the printers, okay, when we talk about printers, we are going to use these colors. Okay. Okay. I will show this one, this monitor one. So actually, we can see that one using Photoshop. Okay. I will show using Photoshop. I think you can see my screen, no? Yes. Let me change the camera. Okay. Okay. So it is blue, no? The camera is blue, like avatar feel. Okay. You have to wait some time. It's like 2 or 3 seconds. Actually, we can, guys, we can just start the conversion for only one or two number system. Okay. Then I will give you some homeworks. Okay, what are those? Okay, I will just create this one. Actually, here, guys, when we use in Photoshop, okay. So here, actually, we have to give the color mode. Okay. This is RGB color. That means when we are designing photos for only monitoring using monitors, only using monitors, we can use RGB color. And here actually we have the CMYK. That means you are going to edit some photo to print. That means you have to use the CMYK color mode. Okay? And also there are several things. And grayscale means not black and white. It's like a black and white. Okay? I just create this one. Okay. The thing I need to show you is here. Okay. I think you can see this one. Here you can see RGB. Okay. Those are the four colors. Okay. Those are the values, guys. And those are the values. Actually, we can give the maximum value as 255. Okay. We can give either more, but the maximum value will be 255. Okay. So let's see. Let's see red. So here in this red, you can see the red will be 255. That means this is the highest value. G will be 12. That means green will be 12. Blue will be 0. Okay. Those are the values, guys. But here you can see a number. Okay. That means these values are represented using hexadecimal. Okay. Here you can see 255 here. Actually, there are 1, 2, 3, 4, 5, 6 digits. Okay. There are 6 digits in our color code. We are calling this one as color code. Okay. So red is 255. When we convert 255 to hexadecimal, it will be FF. That is the maximum value. No? FF. F is the maximum value of hexadecimal number system. No? Maximum digit. FF means, actually here, as you can see, there are 6 digits. That means we are going to use 2 digits for each color. For R, we are going to use 2 digits. For G, that means green, we are going to use 2. For blue, we are going to use 2. You can see 255 is FF, that is the highest value. When we consider green, the value is 12, guys. So you can see, just look into your notebook, the value of 12. What is the symbol? I mean, digit is C. No? You can see 0C. 0C means what? That is the value 12. Okay. The blue, we have 0. That means 0, 0. Okay. Did you guys understand? Actually, when we are using color codes, okay, we are using 16, that means hexadecimal number system for represent 3 colors. Okay. As you can see here, red will be represented in FF means the highest value. Okay. The value is 255. Okay. 0C for green and 00 for blue. Actually, I can just change the values. Okay, let's see, 56 for red, and let's see, 2C for red green. Okay, and let's put a small value for blue. Let's see, 12. This will be the color of this color code. Okay, did you guys understand? In the computer, we are going to use color codes. The color codes, okay, the color codes will be started using hash. Okay, hash, or else color codes will be start using at hash, at hash. Okay, those color codes are indicated using hexadecimal. Here you can see the CMYK. Okay. I will just increase this one as 100% and this one as 0%. You can see the color of see cyan. Cyan is like this color. Cyan is like this color. Let's see magenta. It is like this pink, not pink, no rose. Okay. This is magenta. Yellow means yellow color. Okay. E means what? Black. Okay. So likewise this. Okay. That is the what CMYK color range. So what about here? What if I put 0 for every red, green, and blue? What can be the color? If I put 0 for every colors, what will be the color? Yes, it will be black. Okay, here we can see black. If we write, I will write FF here. FF for every color, it should be white. Okay. So here it will change. Okay. So to print white, we have to put 0 for every color. To print black, we have to just increase the black key. What if we increase all the things? It is also black. It is also black. It is the darkest black. Okay. It is the darkest black. If we put 100 for only key, it is a little bit lighter, no? Light black. Okay. Okay. That is the thing about the 16th. That means hexadecimal. Okay. So okay. Okay. Let's move to the next topic. So actually, guys, I have included that part to our tute. That's why I'm not going to give you the note for that part. I will just give me 1 minute or 2 minutes. Just write the topic. Just write the topic. Least significant digit. Or else I will write. Just wait. Just wait. We are going to learn about the least significant digit and the most significant digit. It is very easy, eh? Very easy. Least significant digit, LSD, most significant digit, MSD. Okay. What is this one? Least significant digit and the most significant digit mean when we consider a number, okay, when we consider number, when we consider this number, the greatest place value and the least place value. I mean, the highest place value and the least place value. When we consider highest place value, this will be the most significant digit. When we consider least place value, this will be the least significant digit. Place values mean the weighting factor. Weighting factor. Here you know we have 0th weighting factor. Here we have 1, 2, 3. So the largest weighting factor is 3. That means the largest place value. That means 2 is the MSD on this number. 8 is the LSD on this number. Okay, that is about MSD and the LSD. Okay, most significant digit and the least significant digit. Very easy. Okay, very easy. Let me write another number. What about this one? If we write this one, you can see this one will be the most significant digit. This one will be least significant digit. Okay, very easy, guys. Very easy. So let me give you this number. Okay, 120. Or as 12. 12. So when I give you 12, you can see the most significant digit will be 1. 2 will be the least significant digit. Okay, 12 is the value. 12 is the value. So if I put 0 here, is the value change? Previous we have 12. So now we have 112. Sorry, 120. No, that means value has changed. Value has changed. So in this case, this 0 can be the least significant bit. No, this 0 can be a least significant bit. Okay. What about, I will just remove this one. What about if I put 0 here in front of the value? What about this one? When I put 0, is the value change? When I put 0 in back, the value changed 12 to 120. If I put 0 in front of here, the value didn't change, no? 12 is still 12. So in this case, guys, this 0 cannot be the MSD. Okay? Cannot be the MSD. More significant digit will be also always as previous 1. Okay, that is the thing you have to learn. What is that one? If we put 0 in front of any value, that means you know the weighting factor here will be 0. Okay, weighting factor 0, 1, 2, 3. Okay, the highest weighting factor is 3. That means the MSD should be 0. No? But when we consider the value, the 0 do not affect to the value. Okay, that means this 0 cannot be the MSD. Okay? That means always not the highest weighting factor is the MSD. This 1 is the MSD. Okay? But when we consider the right hand side, 0 can be a LSD. Zero can be a LSD. This one can be a least significant digit, but zero cannot be most significant digit. Okay, that is the thing. Did you guys understand? Okay, good. So let's write. Okay, I will just write like how can we put this one? Let's write MSD, LSD. Okay, in here MSD will be 2, here it will be 8. 12, MSD will be 1, LSD will be 2. 0, 12, MSD will be 1, LSD will be 2. 120, MSD will be 1, LSD will be 0. Let's see, 132, MSD will be 4, LSD will be 2. Okay. Let's see fraction numbers. 68.34. What will be the MSD? Should be 6, no? LSD should be 4. Okay. MSD should be 4. And then, what about this? 0.8. This is the number. What will be the MSD and the LSD? What can be the MSD and the LSD? Yes, okay. Good. What about Janot? Janot, no? Janot, what will be your answer? What is your answer? Yuvesh, what about the what? MSD. MSD. What will be the values? Janot, at least tell me one thing. What can be the answer? Anything. I'm not going to blame, okay? I'm not going to blame, oh, this is wrong. Go and do something like this. I'm not going to do anything. I'm not going to say anything. Okay? Just tell. MSD will be 8 as well as LSD is also 8. Okay? This will be the answer. If you have one value. Okay. All right. If we have this one, 0.078, 2, MSD will be 7, LSD will be 2. Okay. Yes, good. Let's write. Okay. Just write the topic. Least significant digit and most significant digit. Least significant digit and most significant digit. Least significant digit and most significant digit. Right. In an integer, in an integer or fraction number in an integer or a fraction number, the position with least place value, no, highest place value, just right. The position with highest place value, the position with highest place value is identified as the position with highest place value is identified as MSD. Just write MSD because we have written the most significant digit in our topic. No? Just write MSD. Highest place value is identified as MSD, and the least place value as LSD, as LSD. This is a table, guys. Okay, this is the number, and this is a table. I can't draw good. Okay? I can't draw well. Not well. I can't draw well. Okay, this is a table. Just draw this one. Then hands up. Good. Let's move to the next topic. It is the same, guys. Least significant bit. Okay, least significant bit. And more significant bit. LSB and MSB. Where do we use bit? You know. Where do we use bit? In which number system? Binary number system, no? Yes, good. Binary number system. Every number systems, in every number system, we are calling one symbol as digit. Okay. But when we consider binary number system, we are calling one symbol as digit. No? We have learned that part. So that means it is the same, but the numbers will be in binary number system. Simple. Simple. Let's draw a table. Let's draw a table. Okay, number. Most significant bit, MSB, and least significant bit, MSB. Okay. All right. So the first number, okay, we can write first number as 110. Okay, 110. That means it is the first number. When we consider MSB, it will be 1. When we consider LSB, you know, if we have a 0 in the least value point, we can write that one. 0 will be change the value, as well as 12 to 120. We can say 0 is the least significant bit. But here also, guys, we can't, if we have a 0 here, we can say most significant bit as 0, like previous. So what about this one? 0, 1. If we have this one, so the most significant bit will be 1. Least significant bit is also 1. Okay. So there is a confusion. No, there is a confusion. If don't delete messages. Okay, there is a confusion. What is that one? So here MSB also 1, LSB also 1. Which one? There is 3 ones. Which one? No, there is a little bit confusion when we consider binary number system. So in that case, actually, we are going to put the weighting factor also. Okay, we are going to put the weighting factor also. Here, we can say 10 to the power 0, 1, 2, 2. Okay, here we can say 10 to the power 4, 0, 1, 2, 3, not 3. Here 10 to the power 0, 10 to the power 0. Okay, likewise, we have to tell this one also, but it is better to write like this, but if we write these things also, you will have the marks. Okay, let's see a fraction number. Let's see a fraction number. In the fraction number, if we write 0, 1, you know, most significant bit will be 1. Okay, actually, guys, in the binary number system, most significant bit cannot be 0. Likewise, here, most significant bit digit cannot be 0. Likewise, here also, most significant bit digit, bit cannot be 0, but least significant bit can be 0. Okay, not always 0, can be 0, but here most significant bit will be always 1. Will be always 1. So the thing is, the weighting factor will be changed. You can put 10 to the power, it doesn't matter, or else 2 to the power. Okay, either way, you have to put the weighting factor. Okay, 1 here, 1, 2. What about this one? If we put this one, if we put this one, what will happen? What will happen? Actually, guys, are you guys using AI tools? Are you guys using AI tools? AI tools means ChatGPT, Gemini, Claude, likewise, those AI tools for as a chatbot, and also there are several other AI tools also for image generation. We have Dolly, likewise. Do you know about these things, and do you use those things? Good. Okay, I'm recommending, guys. It is good to use AI tools because the technology has evolved. Okay, when the technology is going to evolve, you have to adopt those things. Okay, or else we are going to like our grandmothers and granddaughters, not granddaughters, grandmothers and grandfathers. No, so if there is a new technology, we have to adapt. Okay, or else actually, guys, when you guys go into the industry, I mean, when you are guys going to do a job, okay, let's see if it is a software engineering job. Okay, There is a software engineering job, and you are going to do that job. So the thing is, you are hating AI. Okay? We can do anything without AI. Okay? I'm not going to use AI at any cost. Likewise, you are thinking in that manner. Okay? So the thing is, you are going to do a job. Okay? So then there is another person that is going to use AI. Both of you will have a same project. Okay? So the manager will come and tell you, so just build up a web page including these things. Okay? Both of you will have same project. So the thing is, you are going to write everything because you are not going to use AI. You're going to write everything. The other person is going to use AI. So he's going to give his command to the AI, and then AI will generate the web page. Okay? But it is not the full film. It is not. It will be, there will be several things inside that generated website. Okay? The thing is, he is going to generate a website using the AI tool, and he will correct the errors. Okay? There are several errors about the placing the button. Likewise, placing the images. Likewise, there can be several errors. The thing is, he's going to generate a web page and fixing those errors. What you are going to do is, you are going to build up a web page initially from the beginning. Okay? What will we do? What will be the difference? He will be complete his project within 2 or 3 hours. Okay? Within 2 or 3 hours. But you will take three 3 days, 4 days, or else 1 week. Okay? So then he will survive. You have to go to another job. Okay? That's the thing. That means you have to adapt to the new technology, guys. Okay? You have to adapt. So use ChatGPT or Gemini. There are several things, but use those for education purpose, not for anything else. Okay, not for anything else. But you have to keep in mind all the things telling in that AI websites are not true. Okay, all the things are not true. Okay, you have to filter. All right. So what will be the answer? The answer, actually, here most significant bit will be 1. When we consider least significant bit, guys, in the fraction numbers, okay, when we consider least significant bit in the fraction number, it should be 1. This 0 cannot be there. Okay. The fraction number, this is the highest value. Okay. So this 0 don't have any value. No? Like this. Here 10 to the power 0, 1, 2, 10 to the power minus 1. Okay, likewise this. Let's see. 0, 1, 0. 0.011. What will be the most significant bit? Most significant bit will be 1, which is this one, 10 to the power 1. Least significant bit below, so 1. What? 10 to the power minus 3. Okay. What will be the most significant bit and the least significant bit? When we consider this one, most significant bit will be 1, no? This one. 10 to the power 0, 1, 2. Least significant bit. Here we have the fraction number, but the floating point also, those things are also 0. That means there are no values in here. So the last value is this one. No? Last value is this one, this 0. That means 0, 10 to the power 0. You got that? Uh, the values are not aligned, okay? Values are not aligned. You have to write in a good way. Okay, did you guys understand? Let's see if you guys understand about the MSB and the LSB. Yes, good, good. Altaf? Ah, yes, yes, not Altaf. Janot, what about you? It okay? Janot? Are you asleep? Hmm? Are you sleeping or else, are doing another thing? Janot, are you there? Ah, good. Wake up, okay? Wakey, wakey. Okay, let's see. Let's write. Uh, just write the topic. Least significant bit, LSB, and the most significant bit, MSB. Okay, let's write. In a binary number system, in a binary number system, in a binary number system, the positions with highest place value, the positions with highest place value, with highest place value, and lowest place value in binary number system, the positions with highest place value and lowest place values in an integer, in an integer, in an integer or fraction number, in an integer or fraction number are identified as are identified as are identified as MSB and LSB. MSB and LSB. Okay. Second point, write as point 4. Second point, when reading a binary number, when reading a binary number, from left to right, when reading a binary number from left to right, from left to right, the non-zero bit, the non-zero bit, the non-zero bit the non-zero bit at the leftmost edge, at the leftmost edge. At the leftmost edge is the MSB, and the bit at the rightmost edge is LSB. Bit at the rightmost edge is LSB. LSB can be 0 or 1. Okay. Next point, for fraction numbers, the non-zero bit to the right of the decimal point, the non-zero bit to the right, yeah, to the right of the decimal point is the LSB. Okay. Okay. Draw this table. This is a table. Okay. Then hands up. We will do conversion for two number system. Okay. Is it okay now? I will take another 10 minutes. Okay. I will take another 10 minutes. And we will do conversion for two number system. Those are very easy, guys. Okay. Then I will give you homework. Okay. Janot and Janot. Raise your hand once you finish. I will be quick. Okay. Janot, finished? Raise your hand. Okay. Once you finish. Is it too bright, guys? No, no. If it is so, just tell me. Okay? Is it too bright? Unclear means is the question is unclear or the board is unclear? If you can't see the board, just tell me if it is too bright or too dark. Now it is clear now. Here, can you see? I just decrease the brightness. Okay. No. I think it is clear, no? Okay. Let's move forward. Janot, is it okay? Is this okay? Yes. I will clean this one. Okay. I will be quick. Okay. So we are going to learn how to convert between number system. Okay. So first of all, we are going to learn to convert decimal number system to each of the number systems. Decimal number systems to binary and decimal to octal, decimal to hexadecimal. Very easy. Okay. Same procedure. For all the conversion, decimal to octal and decimal to binary and decimal to hexadecimal, same procedure. Okay. Same procedure. Okay. Let's see. Decimal to uh, decimal to binary. Who left? Okay. Decimal to binary. Very easy. Okay. I will get a decimal number. Okay. Let's see what will be the number. 46. The first number 46. Okay. What you have to do is here you have to use the mathematic part. Okay. What you have to do is, guys, you have to divide 46 by 2. Why 2? Because we are going to convert this decimal number to binary. You know, binary means what? 2. Okay, binary means 2. That means we are going to divide this number by 2. So we will have the number 23 and we have to put a dash and write the remainder. Remainder. Here actually it will divide perfectly. That means there are no remainder. There is no remainder. The remainder is 0. But you have to put the 0 also. Okay? You have to put the 0 also. So let's see. Let's divide this one again. Actually, guys, you have to divide the values until it gets 0. Okay. Until it gets 0, you have to divide the values and put the reminders. That's the thing. Okay. Okay, good, good. Okay. So here, I'm going to divide this again. 1, 1. There is one reminder. So 22, 11 multiplied by 2 means 22. Here we have one reminder. Okay. Again, I will divide this by 2. 5. The value is 10. Again, we have one reminder. 2. Again, 1. 1. There is no reminder. Okay. Actually, we can stop whenever we get a value less than the dividing value. Okay. It is okay. Okay. If we get a value less than dividing value, we can stop here. But in your note, in your school book, okay, your book, they say we have to divide until it gets 0. I will tell what will be the changes. Okay. If we divide this by again 2, here we have no values, that means 0, and we have one remainder. Can you see? This one is moved to this here. That is the only change. That's the only thing have changed. But when you are going to write answers in O-level paper, okay, O-level paper, I think as well as it is good to write in term test also. You have to divide the value until 0. Okay. But the thing is, actually you don't need to divide the values until 0 because this last value will be come to here. Okay. You can stop your division whenever the value is less than the dividing value. Okay. So the other thing is, at last, we are going to write the reminders from bottom to up, top. Okay. From bottom to top. You have to keep that in mind. Okay. From bottom to top. That means here we have 0. We are not going to write 0. Okay. You know, because if we write 0, it doesn't matter. No. So what will be the value? 1, 0, 1, 1, 1, 0. 1, 1, 1, 0. This is the second base. That is the method. Very easy, no? Very easy, no? What's up? Is it okay? Is it okay, guys? Yes, good. Alta? Yes, good. Let's see. Let's write first. Okay. Put the topic conversion of number system. Write the topic conversion of number system. Conversion of number system, and then write that subtopic decimal to binary. Subtopic decimal to binary. Okay. Okay. Then write like this. First step, or else just put 1. Okay. 1. Divide the decimal number. Divide the decimal number until the value 0. Until it becomes, divide the decimal number by 2 until it becomes 0. And put the reminder put the reminder for every division. Put the reminder for every division. Put the reminder for every division. Okay. Second step, write the reminders. Write the reminders from bottom to top. Write the reminders from bottom to top. Write the reminders from bottom to top. Write this one, and I will give you some homeworks. Just raise your hand. Good. You have to do these things. Okay. I will stop now. Okay. I will stop now. The thing is, I will just I will just tell you. The thing is, guys, here actually we are going to convert decimal to binary. Binary is 2. So that's why we are going to divide by 2. The decimal value divide by 2. So what about when we convert decimal to octal? When we convert decimal to octal, octal means 8. That means if we have a decimal value, we are going to divide by 8 to convert to octal. Okay. Then as like this, we are going to write a value and write the remainder. We are going to again divide, write the value, write the remainder. Likewise, same as this, we have to divide until it gets 0. And also for hexadecimal, I will tell you in the next tip. Okay. Let's write those things in the next tip. Write these things. Okay. You have to come up with the answers. Okay. So we will check whether those are correct or wrong. Okay. All right, guys. I think you got clear understand about these things. Okay. Good. And also you have worked very well. You have told me the answers and everything. Okay. Good. Okay. Let's keep this one as well as the future. Okay. Okay. So I will conclude the class. Okay. So let's meet in the next week. So stay safe, guys. Stay safe and okay. Goodbye. Goodbye.